Hi everyone, Assalamualaikum. In this video, we are going to discuss limits of trigonometric functions. Before we dive too deeply into trigonometric limits, I need to show you a special limit theorem which offers up a handy trick. There are two special limits involving sine and cosine, which we will use again when we study derivatives. There are limit x approaches 0 sin x over x equals to 1. And limit x approaches 0 cos x minus 1 over x equals to 0. Right? Actually, if we use direct substitution, when we plug in 0 into variable x here, we will get sin 0 over 0. And sin 0 equals to 0 means that we will get 0 over 0 when we use direct substitution. But under squeezing theorem, limit x approaches 0 sin x over x will equals to 1. Alright? And for this limit, when we have limit x approaches 0 cos x minus 1 over x, if we use direct substitution, we plug in 0 into variable x here, so we will get cos 0, which is equals to 1. 1 minus 1 equals to 0. And we have denominator equals to 0. Means that if we use direct substitution, the answer gives 0 over 0. But under squeezing theorem, limit x approaches 0 cos x minus 1 over x will equals to 0. Right? This theorem can be proved using the official definition of limit. We won't prove it here, but we just use this theorem. Right? Alright, now let's relook at this. Limit x approaches 0 sin x over x equals to 1. Limit x approaches 0 sin 2x over 2x equals to 1. And then limit x approaches 0 sin 3x over 3x equals to 1. Limit x approaches 0 sin 4x over 4x equals to 1. Right? And so on. The denominator and the argument of sine must be exact same expression in order to properly use the special trigonometric limits. Right? We look at example 1, limits involving trigonometric function. Find limit x approaches 0 sin 2x. Right? If we use direct substitution, from the given question here, we just plug in 0 into variable x here. Then we get sin 2 times 0. And after we use direct substitution, no more limit expression. Okay? Then we simplify, so we get sin 0. And using calculator, sin 0 equals to 0. Alright? It's okay when we get the answer 0. Okay? It is accepted. Right? Because this is defined. Right? So, we no need to use squeezing theorem in this question. Alright? Right, how about example 2? Find limit x approaches 0 sin 2x over x. Let's say we use direct substitution. From the given question, we plug in 0 into variable x here. Okay, so we will get sin 2 times 0 over 0. Then we have sin 0 over 0. Using calculator, sin 0 equals to 0. And then we have over 0 here. Alright? This is error. because 0 over 0 is indeterminate, right? In this case, we need to use squeezing theorem. We cannot use direct substitution, right? Now we look at the correct method to solve this question. From limit x approaches 0 sine 2x over x, we have the argument of sine equals to 2x, or this is the angle of sine, right? So we need to refer limit x approaches 0 sine 2x over 2x equals to 1 from squeezing theorem. From squeezing theorem, the denominator should be exactly equals to the argument of sine or the angle of sine, right? Never change the angle of sine, right? But we need to adjust the denominator, right? So what should we do? From the given question here, we multiply both numerator and denominator by 2 because we want denominator equals to 2x, right? Since we multiply the numerator and the denominator by 2, that means we multiply by 1. And when we multiply by 1, it will not change its original value. Right? That's why we need to multiply by 2 to get denominator 2x. And at the same time, we need to multiply numerator by 2 so that we multiply by 1. Right? Right after that, we can move out constant 2 from limit expression here, okay, using the properties of limit. Right? Then we get this. 2 limit x approaches 0 sine 2x over 2x. Right? From here, we have denominator exactly equals to the argument of sine or the angle of sine. So, we can use this squeezing theorem. Right? So, we can write 2 times 1. Okay, 1 here from squeezing theorem here. Right? And we simplify, so we get equals to 2. Alright? Right, now we look at other technique. From the given question, limit x approaches 0 sine 2x over x. Let's say we write this. Okay? Limit x approaches 0. We move out constant 2 from 2x here. Okay, so we get 2 sine x over x, right? And then, from properties of limit, when we have multiplying by constant, so we can move out from limit expression. Okay, so we get this. 2 limit x approaches 0 sine x over x. Okay, then from here, we can use squeezing theorem when we have denominator exactly equals to the argument of sine. Okay, from here, limit x approaches 0, sine x over x equals to 1 using squeezing theorem. Right? Then we have 2 times 1, okay, from here, and it's equals to 2. Okay, when we compare, we get the same answer. Right? Wait! Can we use this technique? Are you sure sine 2x equals to 2 sine x? Sine 2x is not equals to 2 sine x. Because if x equals to 30 degrees, let's say we substitute into x here. So we have sine 2 times 30 degrees. Okay, not equals to 2 sine 30 degrees. Because 2 times 30 degrees means 60 degrees. So now we have sine 60 degrees and sine 30 degrees using calculator is equals to 0.5. Okay, So now we have sine 60 degrees and the other side we have 2 times 0.5. 2 times 0.5 equals to 1. And sine 30 degrees, when you calculate using calculator, it equals to 0.866. Okay, so it's not equal, right? That's why sine 2x not equals to 2 sine x. Alright? So please be careful. Okay? So means that this is the correct method. But this is wrong technique and wrong concept. So please be careful. Never use this technique. Right? This is the complete solution and the correct answer. Okay? From the given question, limit x approaches 0 sine 2x over x. We are given the denominator not equals to the angle of sine. So what should we do? Never adjust the angle of sine. But we need to adjust the denominator until the denominator exactly equals to the angle of sine so that we can use the squeezing theorem here. Alright? Alright, when we multiply denominator by 2, we need to multiply numerator by 2. Because when we multiply both numerator and denominator by 2 means we multiply by 1. So it will not change the original value. Alright? Got it? Coming up next, evaluating limits using squeezing theorem, example 3 and 4. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.